the next point.
So,
Okay, here they want me to. The first one, what you told is tags. Okay, tags means each one of the device you have is called a tag. And that tag will have set points. That's, um, the tag will have a set point. Okay, whether it is high, low, high, like that. Then the when the set points, anything comes, exception. How to handle the exception. Okay. Then next point is SCADA gives mimics. Mimics means it shows on the screen to you the whole process. So you can see live. Next topic is what he told is alarms. If the exception have the alarm, suppose boiler is very hot, too hot. Alarm should go to who? Okay, he is the boiler mechanic of the plant. So I must send alarm to the factory manager and as well to the boiler technician. But how to send the alarm? You can have many ways. Send a SMS, cell phone, or send an email, or in his room there will be a speaker, okay, and light. So you give the speaker that alarm sounds and put the light on. So this is what he covered. Understood?
That was the message. Could you define what kind of problem?
Let's say SCADA, you have to define. Because again, you see, the alarm is an output. So you have to give an output of whatever type you want. Clear? Yes, clear. Go ahead.
yeah. So one answer to her question, every SCADA system, you should have the functional process expert. The process expert should sit with the technology expert, but the process expert should define, suppose if it is a cement kiln, what should be the temperature, what are the set points, what are the digital input, digital output, analog input, analog outputs. All that has to be first properly done as a document. The system should be thoroughly documented. All exceptions should be thoroughly understood. And what should be done whenever there is a set point beyond any value goes beyond any set point, what should be done? All this, it is a complete system. So the complete system has to be first documented, completely understood. Engineering designs have to be done, drawings have to be done for the process. Then only you can start a SCADA project. This is very important. Now, after alarms, the SCADA system has the capability to get the values continuously in the backend. That means, suppose if you have defined a temperature of a particular set point at 50 degree for a tag called boiler temperature, say the tag name is boiler temperature and it is 50 degrees. It will never be 50 degrees accurately from the process because it would go anywhere between 45 to 55 with an accuracy of point not one or whatever is the accuracy, whatever is the number of decimals in fraction, but the values will be continuously coming into the system as a recorded value. Say for example, if you are riding a car and if the car is going at 60 kilometers per hour, the 60 needle that is shown on the display will always keep generating that value continuously because the car is in continuous motion. Similarly, for any SCADA system, there is a huge backend value in the form of, for every tag, various values keep hitting the system into the system database it within a nanosecond. That is the frequency at which the data is generated and pushed into the SCADA system. So this is called a SCADA database. So in this database, from this database, the process trend is shown as a graph. So the process from these continuously generated values, a graph is shown on the console along with the mimic to make you for the process expert to understand what is the trend of the boiler temperature. whether it is falling below 45 or is going 55. At a single view, one can understand what is the process, where how is the process going, or how is the process happening. So this part of displaying the process values in a graph is called trend. It is called trends. So like mimics, there is a concept called trends in the SCADA system. So various processes can be defined and there could be an overlap. That means on temperature, you can overlap one more trend. On that, you can overlap one more trend. Say the temperature from multiple motors can be superimposed on one above another, and you can still understand whether the entire kiln is happening properly or not. So, for example, a cement kiln has got 600 motors. So, a cement kiln for maintaining 1000 degrees temperature, it needs 600 motors to continuously work to maintain that motor. So, that is the kind of a volume, or that is the kind of a system we are talking about in SCADA systems. Say, for
Okay,
example, yeah.
I will explain with that. What is his trend? Trend, TREND. Okay. Example is a solar pump. I'm giving a solar pump. Now, sunlight is coming, so solar getting voltage. Okay, solar panels are getting a particular voltage. This voltage will be continuously recorded. So this data, how it goes, he says, from the SCADA system, 1 nanosecond. 1 nanosecond means what? 1 microsecond means 1 micron means 1,000 and 1,000. Okay, 1,000 and 1 million. 1 million of data will come in a second. Now, 1,000 million is called nano. So data, so much data will. Now, for example, you can see how the temperature varied from morning 9 o'clock to 3 o'clock. And you also can measure how much the pump outputs, how many liters per minute. Okay? So what he told is you can put the graph of voltage, the sunlight voltage, then you can put pump output on the top of it. That's what he meant. One graph on the top of one graph, you can overlay. Okay, overlay the trend. Trend is the graph, how it was working. Okay, thank you. Please continue.
Yeah. Now, system we have defined, we are discussing about the modules. One is the set point, then the next is the deviation, the tag, set point, deviation, and mimics, alarms, and trends. So we have so far covered these six. Now, there is a concept called historian. What is historian? Historian is based on the trend data, you can move the trend back and forth, especially back, and understand the process as of yesterday, as of last month, as of last week, and you can analyze the trend. That means, how was my process for the last 10 days or 15 days? And this is all real time data. So, the historian is another module of SCADA which will give you the trend and the analysis of the process. That is called historian. So the modules of SCADA are basically the tags with the set points. Then basically that is going into the graphical form mimics. From mimics, you are getting alarms. From alarms, you are also parallelly getting, when there is a real-time deviation, you get alarms. Otherwise, you get trends. From the trend, there is also a trend analysis, which is called a historian module.
Okay,
On top,
wait.
yeah.
You understood historian? Okay, I give a thought. Then use you. So, for example, you are measuring the voltage and the pump output from the solar pump. Now, you can see it, how it was last week. You can see the graph like that moving from before 10 days, how it was, how it is coming yesterday, how it is today. This will be very useful. For example, when you want to make some small changes, then you know whether the effect is there, for example. So this is history. History, you're analyzing the history. So it is called historian. It's very useful, for example, even to track the sunlight. Okay, this period you get the good sunlight. Okay, you can track even for months, whether it's winter months, summer months, rainy season, how much it is coming. That's called historian. Please continue.
Yeah. Now, the entire SCADA software has got graphical user interface called GUI. Now, GUI is basically you can drag and drop, you can display or you can present every particular set point process in the graphical form, mimic it in real time. Suppose if a motor is on, it mimics in real time that the motor is on. And if the kiln is rotating, you can show the rotation as per the speed, you can calibrate. So, the important aspect in SCADA system is calibration. So, whatever is the process, the speed of a fan or the set points, everything can be calibrated perfectly in a SCADA system. This is an important aspect of SCADA system. Now, when it comes to communication, there are various problems in communicating with real time in devices on the factory or with a RTU or with a DCS. So RTU means remote terminal unit, DCS means distributed control system. So we are referring to various PLCs or subsystems through which communication has to be established. So there are some devices, say for example, there is a temperature controller from RKC Japan. They are world leaders in temperature controllers, but they don't give any communication. They will only give an RS-232 port and they don't give any protocol. So you have to write your own driver to interact with that controller in C, in language C. That is called a driver. Driver is nothing but a communication program that will exchange data between the controller and the computer system on the server is called a driver. It's again a request response
Well,
mechanism. Yeah,
uh, there are 2 points he told now. Okay. After that, historian, you can see history. But now you see, you want to calibrate some value, the sensor. Okay. For example, flow sense. So it has to be recalibrated. So how to calibrate? You can calibrate from SCADA. Direct. You can make the set point for the calibration also. You can set from there. Understood? What Indian is going to say RT. I will come, I'll come. They will see afterwards. You don't worry. That's RTU, what you're going to see, PLC. Okay. In SCADA is one system. You select many of the devices, PLCs. Some PLCs work with RTU mode, some work with BCS mode. Okay. This he will not explain now. He will explain afterwards. Okay. Now, what he told, another one is important is the communication. Suppose I make the best flow meter, but I will only give RS to it. Okay? Only I will give RS to it. I will not give all bus, I will not give all these things. So, but RS-232 is available also in SCADA. But to communicate to others, you have to convert that RS-232 to other protocol. So that in SCADA you can write the driver. It's called driver. Understood?
How to calibrate from the SCADA? I think, for example,
Calibration, for example, temperature calibration. Okay. What is the, you will set a parameter. This is a measurement of current and this should be the temperature. Right. So you think calibration has to be done, you can calibrate and set the calibration again. Okay? If you know the calibration. But the calibration has to be done on the site, so on the instrument. That is different. You do on the instrument, but the data also can be taken from SCADA. Suppose one instrument you are calibrating, for example, energy meter. Every 3 months you have to calibrate. So once you calibrate, then afterwards, similar equipment, same time, we can probably put the same calibration also. So the calibration, if you want to do it, it will help you.
The calculation is the same as from the manufacturer.
Yes, could be or can be different also. Because most of the instrument has to be recalibrated after certain usage. You cannot have manufacturer also. If energy meter, every year you must get a certification, for
correct.
example, right? Yes.
depends on the requirements of the location where the what streets to be replaced. I mean, maybe you buy a motor. From the manufacturer, they said, for example, 55 degrees. Let me say, so it cannot be calculated depending on the climates.
No, what you are talking about, manufacturer gives temperature. This temperature model, you cannot calibrate that. Okay. Calibration is reading value, converted value. For example, a thermocouple that gives the voltage and then it converts to temperature. That is called calibration. But what you are talking about, limits. He says the motor has to work only up to 55 degrees. You cannot change to 60 degrees. You cannot do it. Okay. Listen. Next one. Continue, please.
Yeah. So after this, we discussed about communication driver. So one method of talking to the RTU or to the controller is device driver. A driver will exchange the data between the controller and the SCADA system. The other method is protocol like Modbus or Profibus, or there are many other protocols in the industry, but these are the leading. One is from Siemens, one is open source. So a protocol, if it is already there, if you are using a standard equipment like Siemens PLC, it will give Profibus protocol, which can be directly, you can start exchanging information between the SCADA software and the PLC. When there is no protocol, you can use drivers, device driver. And if there is a PLC, say for example, Mitsubishi PLC or Fanuc PLC, but they are giving proprietary protocol or some kind of a changed protocol they gave, which they will try to customize for their own version. Say, for example, they will give a Modbus, but that Modbus will not be the original Modbus. They will make some changes to the Modbus and embed into their PLC. In such cases, and in all protocols, you have a standard now called global standard called OPC-UA. You can write it down, OPC-UA. Object linking and embedding for process control is the acronym of, it's an acronym of object linking and embedding for process control, OPC. UA means unified access. So this is a global body where every protocol is defined here, and you can use OPC UA as another communication. So there are three types of communication. One is basic driver, device driver, which you can write, or you can use the OEM Profibus or Modbus or any kind of a protocol which comes from the OEM. And if not, you can use OPC UA. For example, if you don't have a Siemens Profibus protocol, you can still use OPC UA to communicate with a Siemens PLC or an Allen Bradley PLC or a Fanuc PLC. So these are the three important communication methods in a SCADA system.
Is it clear for you?
OPC.
Okay. See, you have a manufacturer, he gives a certain protocol. If that is not available, they support, the manufacturers mostly support the open bus, okay? OPC, what you told. So you can use that.
OPC.
If somebody doesn't give any of the protocol, you use device driver. So like I told you, only RF systems will come in, then you can write a program to convert it to other program. That is what he told. Continue, please.
OPCUA means what? OPC. Below what?
OLE for process control. OPC means OLE for process control. Again, OLE means object linking and embedding. It's basically a Microsoft standard for data exchange.
Yeah, wait. Object linking and embedding, OLE. This is any programmer will know who works with Microsoft. Object linking and embedding.
You can simply mention it as OPC UA.
Just you Google and find out OPC, you'll
OPC
find out.
UA is the standard other than drivers and the protocol. We are discussing because
You can
these
do
are
a
the
lot.
different types of communication. Yeah.
Go ahead, please.
Yeah, okay. Now, lastly, the RTU is used for oil and gas pipeline or railways. Basically, RTUs are kept along the pipeline with a distance of 50 meters. And that is called used, basically RTUs are used for oil and gas, water pipeline, SCADA. Then DCS is used for a very accurate, safe process. Say, for example, there are certain factories like glass factory which want, or a steel factory, they want DCS systems. Apart from SCADA, they want DCS. So there are so many processes, subsystems that needs DCS. So DCS is usually a system in a factory which is a closed loop system, and RTUs are used for oil and gas, which are widespread in the field. And other SCADA is basically cement SCADA, or maybe, power SCADA or water SCADA, which is a control room, which is there where you can look at all processes, manage all alarms, understand the process, look at the graphics, look at the historian, and do all these things. So SCADA essentially has got a control room wherein the control room will have all the points connected to the control room. Infrastructure will have systems, servers, and various operators, functional experts, technical experts, understanding the process 24/7 throughout the day, throughout the year, on a continuous basis. It's a real-time job. SCADA control room is a real-time job. It's not a batch, it's a continuous job. That is very important. Now, with this session is over. I have covered basic SCADA for you, communication, the modules in a SCADA system, and I gave you some examples, and I told you the difference between an RTU and a DCS and a SCADA system. RTU and DCS are subsystems for a SCADA system. If you have any doubts, we are open for discussions now.
Last what he told is a control room for SCADA is very important. It is not that once you put a SCADA, it does everything automatically. You require a control room. I have seen a control room in oil refinery in Baroda before 35 years. The control room is such a way that any blast happens, nothing will happen to control. Okay, because very important. Somewhere one part of plant something happens, the control room, if it get damaged, rest of them cannot be controlled. So you have to be careful in most of the installation, secure the properly the control room. So what he has told, I think is clear to all of you, right? He will two things there, RU and DCS. Okay.
Yes.
So that's a different types of PLCs, how they are connected. Okay. Then he will explain what is DCS. Okay. Is there any questions you have for him? Press it speak. There's a switch down there. Okay.
I need more explanation about DCS. DCS on IoT.
That he will explain. There are different ways of PLC how they work. For example, he told RTU is a PLC which works up to 50 meters. Okay. You will see RTU, he is flying here too. He has not started it. Be patient. For RTU and DCS, he will explain. Next person.
Another question.
Yes.
We know the SCADA monitor and the just monitor the system in general, right?
No, it controls also.
It control, yes.
Control as well as monitor and data log.
Yes,
And plus alarms community.
many things.
Yes.
So what about HMI?
HMI, he will explain again. HMI is for individual machine. An individual PLC, locally you can see human machine interface.
Surface, yes.
So
HMI,
operator there. Please,
Yeah.
please go ahead.
HMI is basically human machine interface, is an acronym for say for example, you have a touch panel on the latest cars. You have a tablet device. You can touch it, control it, and you can set your AC temperature in a car. So that is a best example of a HMI. Usually a DCS system will have a HMI attached to it. SCADA system will have directly a computer monitor. So SCADA system can have multiple HMIs as slaves for it. But SCADA system has got a console. In the control room, you will have big LED or LCD screens, the computer screens, desktop screens, which will have the entire process. Usually, SCADA monitors are very large because you will have to capture and see the entire process in one screen. So usually there will be 32-inch monitors or very large monitors, and you will have the entire process in one screen. So HMI is at a DCS level or is at a individual equipment or a machine level. If you look at any machine, which is from any packaging machine or a paper machine or even a boiler from any of the OEMs, you will find an immediate HMI that is attached to it. Don't confuse the HMI with SCADA. HMI is basically an equipment related interface to operate the machine or the DCS at a local level. A touch screen based or a small industrial computer or industrial screen with the computer embedded into the equipment is called a HMI.
So in brief, it's like a controller of the machine.
Right, absolutely.
It's a touch panel for the machine to control the machine. It is not a controller.
Even
It is an interface. Yeah, interface to operate the machine.
you will see a HMI in another 15 minutes. He will show you everything. Okay. Any other question? Okay. I think I have to really thank you from my heart. You're a
Yeah.
real professor. You
Thank-
you can explain so nicely in simple words. Correct? He explains simple the concept. Many people will put lot of presentation, okay, lot of pictures, slide, and they'll confuse you. But this is told the concept of what is Scada, how you have to prepare yourself, what you do. This is what the training program is meant for to you. So you understand the basic concept. I'd like to thank very much Ramaneshwar, my
Thank you,
good friend,
doctor. Thank
my
you,
good
doctor.
friend
Thank you,
for so many
Mukundji.
years.
Yes,
Thanks
yes,
for
yes. Thank
spending
you.
your time.
Thank you, the Rwandan irrigation engineers and team. I wish you all the best. Once you go back to your country, you apply all this knowledge for your real uses and keep in touch with Dr. Ismail. He is my mentor, guru. It means a lot to be here today. Thank you, doctor. Thank you, Mukundji. Thank you all. Bye-bye. Bye. I'm signing off. Yeah.
Thank you.